Welcome my viewers to my YouTube channel. If you come across this question in your exam, how will you solve it? Okay, now let us look at the question very well. The question says a motor truck release at least 5.0 grams of CO, that's carbon monoxide or carbon dioxide, in the air for every kilometer. That is to say, for every 1 kilometer, it releases this amount of CO. Okay, covered. How many molecules will be emitted into the air if the truck travels 8 kilometers? How will you solve this question? Very easy. They gave us the atomic mass of what? Carbon, and the atomic mass of what? Oxygen. So also, this symbol signifies your Avogadro's constant. Avogadro's constant. So they gave us everything we need to solve this problem. If it comes out in your post-utme, this is how you are going to solve it. Remember, I made a video on mole concept, and I told you that if you are to calculate for number of particles, how will you calculate it? For number of particles called Na, okay, small letter Na. For number of particles, particles are referred to as atoms, molecules, and ions. Take note of that. So if you are looking for number of atoms, if you are looking for number of molecules, or you are looking for number of ions, it is equals to reacting mass over the molar mass times your Avogadro's constant, or it is number of moles times your Avogadro constant. So you can determine your number of particles with mass over molar mass times Avogadro constant, or you can use the number of moles times Avogadro's constant. So how do we solve this question? The mass was given to us as 5.0 grams, but we have to calculate for the molar mass of carbon dioxide. So carbon dioxide, the molar mass of carbon dioxide will give us 12 plus 16, okay, and that will give us what? 28 grams per mole. That's what we have. So we have 28 grams per mole. So what do we have to do in order for us to calculate for number of molecules? This is what we have to do. Number of molecules is equals to mass, which is what? 5.0 over molar mass, which is what? 28, times our Avogadro's constant, 6.02, times 10 raised to the power of what? 23. So remember, you are a post-utme student, you multiply 5.0 times 6.02, then you divide it by what? 28. Let's do that quickly. If we multiply this by this and divide by this, we have 1.075 times 10 raised to the power of 23 molecules. So ladies and gentlemen, this is the number of molecules that is released in every 1 kilometer. But they told us to calculate for, they say for every kilometer covered, how many molecules will be emitted in the air if the truck travels what? 8 kilometers. So for 8 kilometers, we'll simply multiply this value by 8. So we can say that for 8 kilometers, we have number of molecules equals to 8 times 1.075 times 10 raised to the power of 23. So let's multiply 8 by 1.075. So if we do, for every 8 kilometers, we have 8 times 1.075 to give us 8.6 times 10 raised to the power of 23 molecules. This is the answer to the question. Let's take 3 other questions before we call it. Now let's take question number 2. According to this question, it said burning of 0.46 grams of ethanol produces heat that what? Raised the temperature of 100 grams of what? Water, okay, by 30 degrees Celsius. Calculate the heat of combustion of ethanol. This is the mass of carbon, mass of hydrogen, mass of oxygen, and specific heat capacity of water. This is specific heat capacity of water. So what do we have to do to solve this question? Very easy. What is the formula for heat of combustion? The formula is the same with the formula for heat of solution. So if we are to calculate for the standard heat of combustion, it is equal to mc change in theta over n. Okay, this is known as the mass of water. You must note that this is called specific heat capacity of water. Then, and you have delta theta, which means change in the temperature of waiting water. Then for this, your n signifies number of moles of the substance. Take note of that. So what does that mean? It means that for this formula, the numerator is basically for water. Then the denominator is basically for the substance. So if I say number of moles of the substance here, as the question implies, is your what? Your ethanol. So what do we have to do to calculate for the number of moles of ethanol? Don't forget that number of moles is mass over what? Molar mass. So what's the mass of ethanol in the question? Was it given to us? Let us check again. Oh, they gave us the mass of ethanol as 0.46 grams. So we need the molar mass of ethanol in order for us to get the number of moles of ethanol. So let's do that quickly. Mass of ethanol, mass of C2H5OH. That will give us carbon is 12 times 2 plus hydrogen is 1 times what? 5. Oxygen here is 16. Then plus your word, your 1. So this will give us waiting now 24 plus 5 plus 16 plus 1. So 24 plus 5, this will give us 29 plus 1. That will give us what? 30 plus 16. That will give us 46 grams per word per mole. So let's get the number of moles of ethanol. So for number of moles of ethanol, C2H5OH, it will give us the mass of ethanol, which is 0.46 over your word now, 46. So what is the number of moles now? The number of moles of ethanol will give us what? Let's do that quickly. 0.46 over 46. I think you have 0.01 moles. But let's confirm it. Correct. So you have 0.01 moles. So what we have to do now, you have to calculate for standard heat of combustion. So your standard heat of waiting combustion is equals to mass. I told you everything here is for water. Okay, everything here is for waiting water. So we have mass of water. What's the mass of water? They gave us that it is 100 grams of water. So you have 100 grams multiplied by specific heat capacity of water, which is what? 4.2. So you have 4.2. Don't forget, the specific capacity of water is 4,200. But whenever the mass is given to you in grams, it becomes 4.2. It must be noted. Then multiply by your change in temperature. You see the temperature rises by what? 30 degrees Celsius. So you have 30 over the number of moles. What's the number of moles? 0.001. So you have 0.01 moles. So what will that give us? Let's multiply this by this by this, divide by this. So if we multiply 100 by 4.2 by 30, then we divide by 0.01. We have 1,260,000 joules. This is the amount of heat. So let's convert to kilojoules as usual by dividing with what now? 1,000. So this cancel this, this cancel this, this cancel this. So what do we have? 1,260 what? Kilojoules. So this is the amount of heat of what? Combustion. Thank you very much. We have come to the end of today's video lesson. If today is your first time of coming across my YouTube channel, subscribe to this channel and on your notification bell so that whenever we come online, you get notification from us. Thank you very much. I'll see you in my next video.